Our next example is a little bit different because for the first time, the substance that we're starting with, sulfuric acid, is not the exact same thing as the thing that we're ending with, oxygen. Oxygen is actually one of the components within sulfuric acid. Remember, sulfurous acid would start with hydrogen and it would end with a polyatomic ion that ends in ITE. That would be sulfite. Since sulfite has a charge of 2 and hydrogen has a charge of 1, we would crisscross the charges, and that would be H2SO3. We're looking for the atoms of oxygen that are within a sample of this entire compound. Now we're still going to start the same way. We're going to start by considering what we already know about the entire compound. We know that 1 mole of H2SO3 is equal to 6.022 times 10 to the 23rd. And really, you could use molecules or formula units here. I'm going to go with molecules since it starts with a nonmetal hydrogen. But really, it also breaks into ions if you put it in water, so you would be just as correct using formula units. We also know that 1 mole is equal to the molar mass of H2SO3. To calculate our molar mass, we take 2 times 1.008, that's our hydrogen, plus the sulfur, 32.066, plus 3 times our oxygen. And we come up with 82.08, okay, so that's 82.080 grams of H2SO3. We're not going to start with our given, just like we did before. And I'm hoping in this example you'll see why I did try to get in the habit of also including my formulas. Unit from the given goes to the bottom. We know our equalities that we calculated. That would be 82.080 grams is 1 mole. And then we know to put the mole on the bottom. And this is where some of you are going to start making some mistakes. You're going to be really tempted to say, okay, I want atoms of oxygen, so I'm just going to fill in Avogadro's number of oxygen up top. But that's not true. What we do know is we know that 1 mole is 6.022 times 10 to the 23rd molecules, not atoms, of H2SO3, not just the oxygen. But what we can do now is start actually thinking in terms of our subscript, because there's something else that we know about oxygen within each of those molecules. If we wanted to build 1 molecule of H2SO3, we would need 3 individual atoms of oxygen. So we know that there are 3 times the amount of oxygen as there are molecules of H2SO3, so we can actually use that as our last step. We would take 18.34 divided by, since it's on the bottom, 82.080 times 6.022, and again I'm going to use that E key, times 3. And that gets us our answer of, let's see, 4 sig figs, 5 sig figs, 4 sig figs. These are actually counts, so they have unlimited sig figs. We're going to round this final answer to 4 significant figures. Now I do quickly want to show you a second way of thinking about it. It might not have been as intuitive as this way, but there is a way that would actually help us with some problems you're going to run into later. And it's going to start the exact same way. We're still going to use our molar mass to get our grams of sulfuric acid into moles of sulfuric acid. But then at the next step, we're actually going to use our subscript as what we would call a mole-to-mole ratio. And this is something we're going to need a lot later on in the year. So I'm just going to introduce it here, and you can use it now or you can use it later. It doesn't matter. If we're looking at an element within a compound, instead of waiting until the end to consider our ratio, we can also consider those subscripts as being ratios of moles. So during this step right here, we could just as easily have said that for every 1 mole of H2SO3, we have 3 moles of oxygen. And then for our final step, we know that 1 mole of oxygen would be Avogadro's number, and the representative particle of an element like oxygen would just be atoms, which would also get us this exact same answer. It's just doing it at a different place, switching the steps around, and using that ratio a little bit differently. It's entirely up to you which way you prefer, but definitely take a minute before you go to the next slide and make sure that those steps kind of make sense to you. If not, email me, come to the Zoom sessions, ask questions. Let's make sure we understand this before we go any further in the year.